In this tutorial, I'll show you how you can perform a regression analysis in R. To get started, make sure that you have the script open so you can follow along with my commands. The first step is to open up the dataset. We can do this with the read.csv command. Let's highlight this line and run. From here, a search window will open for you to open your file. Once you find the file, click Open. In the environment window, you will see my.reg pop up. You can then look at the variables that are in your dataset. Specifically in this analysis, we're going to be using the variables budget through female to try to predict box office. We can see that we have several numerical variables, but we also have the movie names. The next step in getting started with our regression analysis is to attach our data. All this will do is make it a lot easier to reference the different variables when we're performing our regression analysis. Now let's explore our relationships with the scatterplot matrix. We can do that with the pairs command. Notice the structure is y versus multiple x's. This is good structure for us to understand because we can put in our response variable for y. I'm going to type in box office. And I notice that when I start typing the name, it will pop up for me to select. Same thing goes for the explanatory variables. Here, I only want to choose my quantitative explanatory variables. So that would be budget and Oscar noms. I only have 2 quantitative variables, so I can remove this last one. If you have more, you can just add more variables with the plus sign. Now I want to create my scatterplot matrix. I also want to open up this window just a little bit more so I can see it easily. Running the pairs command, I get my scatterplot matrix. Here I can see across the top row the scatter plots that are associated with box office on the vertical axis and my explanatory variables budget and Oscar nominations. I can see between budget and box office there's a strong positive linear correlation. And I can see that between Oscar nominations and box office, there's really just random scatter. So there's not much of a relationship between these 2 variables. Also, what's cool about the scatterplot matrix is it makes a plot between our explanatory variables. In this plot, I don't want to see a pattern because I don't want my 2 variables to be correlated with each other when they're trying to predict my response. One last note about the scatterplot matrix is you only need to look at the plots that are above the diagonal. Everything below just flips the axes of X and Y. Now, another plot that we can create if we want to compare our response variable box office to one of our categorical variables is to type in box office for Y and then use one of our categorical responses. In this case, I'll use my first one, POC, person of color lead. If I run this box plot command, I'll be able to see the relationship between person of color lead and the overall box office. I can see that there's a pretty significant relationship when you have a person of color. It looks like there's a lot higher box office overall. I can do these types of box plots for all of my categorical variables. I'm going to wait though until we get our final model to make some nicer plots. Now I'm going to move on to exploring the relationship with the correlation matrix. With the correlation matrix, I need to use the core command. The core command requires all of your variables to be quantitative. But what I notice about my data is that I have this movie variable that isn't quantitative. You might have this in your data set as well. So you have to subset my.reg data to only include the columns for your quantitative data. So I can do this with this command. Pulling my reg.data, I only want to select columns 2 through 9. Right now, this is just selecting columns 2 and 8. So I can edit this code to include the columns I want. And now I have all the columns, and I'm going to name this new subsetted dataset vars.cm. I'm only doing this so that I can put it into the correlation matrix function. Now I can put it into the core vars.cm command. Highlighting these 2 lines together, I can view my correlation matrix. I notice that it's a little bit hard to see because of the number of digits that I have, but it's okay. I can ultimately see that coming down this column, 0.95 is my budget correlation with box office. Oscar nominations is pretty low. Person of color lead, action or superhero, and drama are all pretty moderate correlations, but horror and sci-fi and female are both pretty bad. There is a better way that I can visualize this, though, through a correlation plot. Going back to my script, you can use this optional code to make a correlation plot. You need to install a new package called CorePlot and Library CorePlot. This is as easy as just highlighting these two lines and running. It might take a second for you to run the install.packages as it uploads all the different functions that are in this package in R. Ultimately, wait a few moments and you'll be able to create this lovely correlation plot. Highlighting all of this code, you can see what the different aesthetics will do if you change them. You put in your core.matrix or your correlation matrix that you named from above and run. Here, opening the window, we'll be able to see our correlation matrix in a heat map. We can easily see across this top row that budget is the strongest correlated variable. Oscar nominations is poorly correlated. Person of color lead, action or superhero, and drama are all moderately correlated. Horror and sci-fi and female are not very correlated. What I like about this plot is that I can also easily see the correlations between our explanatory variables. Seeing that budget and action or superhero is the overall highest correlation between our explanatory variables. It doesn't look like we need to worry about this too much though, because it's less than 0.90. The next step is to build our linear regression model based upon these variables. So in step 5, we use the linear model command to fit a model. I like the structure. This looks a lot like our overall model format. I'm going to start by putting in box office for Y. Then I can put in the different variables that I'd like in my model. Specifically, I'm going to put in budget, POC, action or super, and drama. If you have more than 5 variables, you can keep adding them with the plus. Otherwise, you can delete the extra variables that you don't need. To run this regression, we're going to highlight the code. This model is named model.1, and we're going to visualize the data with summary. Running both lines, we'll be able then to see the output and the table of coefficients. First, we can see that across the p-values, we can see that budget is highly significant. It's also in scientific notation. We have person of color lead, very significant, action or superhero significant, but drama is not with a higher overall p-value. We should likely drop drama from our model. Looking at our adjusted R-squared, it also looks like it's pretty high at 0.927. This is a pretty strong model overall. Let's go ahead and drop drama from the model. The easiest way to do this is to highlight the original code, copy it, and paste it below. Here you will rename model.1 to model.2. Once you rename your model, then you can go over to where it says plus drama, and you can just delete that variable from your model. Re-highlight the same commands and click run. This time we'll get a summary without drama. This time we see that all of our variables are significant and that overall our adjusted R-squared has changed to 0.9289. So it's gone up just a little bit, even though we dropped a variable. Now this will be our final model. So let's go ahead and change this name from model 2 to final model. This isn't necessary, but it gives a cue to you that this is your final and last model. You may have to do a couple more steps than I did to refit your model to get to this final step. I'm going to rerun this, and so I can establish my final model. Now the next step is to get our residual plot. For our final model, we're going to plot the fitted values versus the overall residuals. The rest of this code just provides a nice title and some labels. Highlight the plot code and click run. Now we have a residual plot. We can see that there's no U-shape, no funnel shape, and no imbalance above or below the reference line of 0. One thing we do see is we do see a big outlier here and possibly some outliers up here, but just a few points shouldn't determine whether or not we should transform or do anything more with our data. This looks like a pretty good model. Now the final steps are to make some pretty plots for your final report. One plot you can create is if you have multiple quantitative variables is the scatter plot matrix, but you can add some additional color and some different and a main title. For me, this might look like Y, box office, and my 2 quantitative variables. Even though Oscar nominations isn't in my model, I could still make my scatter plot matrix prettier for my explore part of my final report. So I'm going to put in budget and Oscar noms. I can run this and I can change the title later, but ultimately I can see that budget and box office look really nice. Oscar noms and box office, again, don't look like they have much of a relationship, but I have this nice pretty Dodger blue color, and you can change any of these colors based upon what you see up here. It can be kind of fun to change the colorizations. You can also Google to see what other colors are available. Another type of plot would be a scatter plot where you add color based upon one of your indicator variables. Here, this code will do that for you. The first step is just to put in the categorical variable name that you would like to add to your plot. For me, I'm going to add person of color, so I'm going to change my cat.name to POC. I'm going to use the colors sky blue and tomato for this categorical variable. You can change the colors if you'd like to, but once you've done that, you can run these 2 lines of code. This doesn't actually create the plot yet, but it does set up the colorization for your scatter plot later. Now in your plot, you need to type in your response variable. Mine is box office, and my quantitative variable that I want to create the scatter plot from. In this case, that's going to be budget. Now I can highlight both the plot and legend together. And now I see a scatter plot with both the different colorizations on it. My legend is a little weird. I have it in top left and it kind of got funky. So I'm going to run this again. Now it's up here up at the top, and I can change this categorical variable name to something that represents my actual variable. In this case, I'd put in person of color, and then I can change my title and my other axes titles as well. The final plot that I can create is a box plot. So a box plot I can use with my response variable, so box office, and I can put in my categorical variable. Let's again use POC and run this to look at the relationship between box office and POC. I can see the different colorizations, and I can change these colors if I want to, and ultimately I can put this into my final report, especially if I have a categorical variable in my final model. Once you're finished with your analysis, make sure you save your script. Once you've done all this coding, you don't have to do it again. Even if you want to make edits, you can simply just now run all the commands. This is one of the benefits of using R, is that you don't have to redo everything again once you save your script. Another thing that you can do is you can export and copy your plot to a clipboard. So if I want to put this into my Word document, I can copy the plot. I can bring over a Word document. I can right click and I can paste it as an image. Obviously it came in really big, so I'm going to make it a little bit smaller for my overall plot. I can also take screenshots of the R output. So if I go back to my console, I can find my final model output. Here I can see my different variables, and I can take a screenshot of this and plop it into my final report. And hopefully this video helped you better understand how you can perform a regression analysis while also exploring all your variables and visualizing them in RStudio.